Hello and welcome back to my job tutorial series. Today we'll be doing a unfortunate re-recording of episode 11, which is advanced threading. So I'm just going to start out like any other episode and start with our main class. Now in the last episode, episode 10, we went over basic threading, so we know what threads are, hopefully. So instead of starting out with the main method, I'm going to start out with just two threads. So there's going to be thread 1, and they're both going to be objects that I am going to declare right there, so I can give them a custom run method. So what I can do in here is spell things correctly and give it its own run method, because threads are all about their run methods. Now today we're going to be dealing with concurrency, which is about, waiting and notifying and synchronization and a whole bunch of other stuff. So now we can start with our public static void main string array args. And all we're going to do for now is start both threads. Okay, so now we have two threads. They both start at the beginning, and we can, make them do pretty much whatever we want to say. Yeah, because they're threads, and they can do anything, but they can do, so if you have two threads, they can do stuff at the same time. So, they can both say that. But what's really fun is when you integrate two threads to do things and do different things, such as waiting or sleeping. We went over sleeping in the previous episode, but now we can wait. But there's something very important about waiting, is that you have to own the object's monitor, which we will talk about. So let's just say we have to do this with a try. So we're going to try thread2 dot wait, and we have to catch an interrupted exception, because while it's waiting it can be interrupted, which will add a interrupted exception. Now we won't be doing that, so it will be relatively not likely for that to happen at all. So I'm just going to do this. Now what you see right here, this is a new keyword. It's synchronized. The way I'm using it is just, how I should use it, is that it's mainly a modifier, if I can spell it right at all. It's another keyword that you can append to a method. It cannot be used on variables, but it can be used, well, we'll talk about the variables later, but it can be used on methods. And what synchronized means is that if you have something, if you have a method, then if it's synchronized, that means only one thread can use it at a time. So if we had, two different threads, putting it on run is a bad example, except for what we're about to do. But if you had a method that, a static method that calculated something, and it took a while to do that, and you made it synchronized, if two different threads try to call it at the same time, the first one gets to use it first, and the second one has to wait for the first one in order to do it. But the reason we're using synchronize right here is so that we can get the monitor. So if I just do try thread.sleep, since everyone loves those interrupted exceptions, and we'll just do a second and a half. That sounds reasonable. And when we're done sleeping, we're going to do this dot notify all. Now, if you saw, there's notify, but there's notify, but there's also notify all. They're both methods. And what happens when you call this dot notify, any objects that are waiting on this thread, namely this is thread 2, and thread 1 will be waiting on thread 2. If you call this dot notify all, it will notify every single thread waiting on this object, which just happens to be a thread, but it can be any object. So any thread waiting on this object will be notified, which means they can stop waiting. And just so we know that this would be stop waiting, potentially, we just do print line thread 1 done waiting. So let's see what happens if we try this. We got an illegal monitor state exception because well, this is perfectly fine because it was synchronized. That means when you put synchronized on a method, that means this is a non-static method. So that means we're basically everything in this method is synchronized this, which when I put that down, it's the same as saying this throughout the entire method. Which, this is when you're not using it as a modifier to a method. That means you have this object's monitor, so that means you are allowed to call the notify all command. But what happened here is that at this wait, we tried to wait on it without having its monitor. Like, our notify all worked because it was synchronized. But the reason it threw the exception then is because when we tried to notify it, we realized this didn't have the proper monitor. So if we just make this a bit bigger and do the synchronized, I probably spelled it wrong. Almost certainly, I would say. Oh, cool. Okay, so I spelled it right. So now, if we run it, we shouldn't get an error. So it said thread 1 done waiting. Because what happened, it's waiting. It's waiting on thread 2. So as soon as thread 2 calls a notify or notify all thing, because notify all notifies all threads waiting on this object, but notify notifies one random thread waiting on this object. So if we did notify right now, it would work, but if you had a lot of threads waiting on this object, then notify will give you a random result. So that's why you almost always want to use notify all. So this will wait. So this thread will stand still until thread 2 sends a notify or notify all. And thread 2 is just sleeping for 1.5 seconds or 1500 milliseconds, and then it's going to notify all. So this is essentially waiting 1.5 seconds, and then it's going to be done waiting. So you have to be threading is a very difficult thing. In fact, there's a saying, a programmer tried to solve a problem. A programmer had a problem, and he tried to solve it using threading. He then had 2 problems, because threading can be very difficult, and you have to have a lot of experience with it, which I didn't on my previous episode, which is why this is a re-recording. And the previous episode will be deleted by now, but now I'm just re-explaining so no one gets confused. So that's wait, notify, and notify all. But there's also a join. Now, threads are objects the same. As soon as you start it, this public static void main is the beginning of the new thread, which the virtual environment Java virtual machine creates whenever it starts to execute a Java program, and we can create our own, but they're all objects. And as soon as a thread, reaches the end, it'll dispose of itself and be destroyed. So the main thread that the virtual machine created, as soon as it's done writing thread2.start, it'll destroy itself because it doesn't have anything to do. Now there's another command, another method, I should say, that is the join command. So let's just replace it with this. So join means it will wait. For the wait command as well, they can accept an argument of milliseconds. That, if what they're looking for doesn't happen within that time, it'll just keep moving on. But for example, we'll just use this where it waits indefinitely. What join does, it waits for the thread that it calls it from to be disposed of or to stop running, and then it'll do. So it's basically wait until this thread has nothing else to do. So if you have one thread doing something and you need this thread to wait until it's done, then join is how you would do it. So we can actually run it right now, and it'll wait the 1.5 seconds, and then it'll print this out because this waits for 1.5 seconds, and then it doesn't have anything else to do. So this thread is pretty much gone and eliminated, which satisfies join's condition. So, hey, the thread 2 is done doing its work. We can continue on with ours, which is just printing out that you're done waiting. So there are many different ways to implement this regarding threads. I mean, depending on what you're doing, you don't normally need to make new threads that often, but it is a handy thing to do. But there are several other problems that you can come up when you're dealing with threads or threading in general, and three of these are categorized as liveness or liveliness, or well, probably liveness. And there's three kinds. There's deadlock, starvation, and live lock. And these are three problems. Deadlock is definitely the most common, but starvation and live lock are still potential. So what deadlock is that two threads would end up waiting on each other. And if they wait on each other, they obviously can't notify each other, so they're basically stuck waiting on each other forever. So if we demonstrated this, let me just say thread 1 waiting on thread 2. If I can stop capitalizing that H. Dang. Just copy it over here. I'll just say this is thread 1. Say thread 2 waiting on thread 1, and you can say thread 2 done waiting. And we can just take this out for now, just for the sake of showing it. So now if we did it, we'll say they're waiting on each other. And since they're waiting on each other, then neither of them are going to continue on to what would normally be this dot notify all. And as you can see, it's still running. But if we run it now, I mean, give it a bit more purpose. So they're waiting on each other, so they can't notify each other because they're waiting on each other. So this will keep running on and forever because they're both stuck doing nothing. So that's pretty bad. And that's deadlock, and it's the most common mistake you can do with threading, which you have to watch out for. The next one is starvation. So when I said about the synchronized method, whenever you synchronize, that means only one thread can access that at a time. So let's say you had a really long thread. Let's say you had a method. We'll do public static void synchronized print stuff. I'm assuming Synchronize has a problem. Does that work? Yeah, it works. Okay. So that means this is synchronized, so only one thing can do stuff with it at once. So this is normally a problem when you're using methods that take a while. So let's say it's printing stuff. And it just happens to take a while. So this is a method that takes a while, since it takes, about 3 seconds. So we just change this to, print stuff, and thread 2 here. We change this to do, yeah, thread 1 here. And we did it. As you can see, it waits, printing stuff. Thread 1 got there first, and as soon as it finishes, since it's synchronized, the rest of it can begin. Now, obviously that's a problem if it takes, longer, and multiple things need to do this thing really fast. So how you would fix that, instead of synchronizing, the whole method, you would normally just synchronize parts of the method. So you could do, it wouldn't be very effective considering, what this method is actually doing. You could do synchronize message, perhaps. Which, that means, both things can, print stuff at the same time, which is good. Except when you're actually, going to print this message, they're not going to be printing at the exact same time. I mean, printing out takes, just a couple nano or milliseconds. Well, maybe a little less than a millisecond. It depends, on your computer and processor speed and all that stuff. But, obviously, to us, it appeared as if these print out at the same time, but these probably printed out. Since, those are very fast operations, it doesn't really make a difference. But, programmatically, it does. Because maybe you're changing message in this method, and you don't want to change, and it's a static method, so different things can call it at the same time from different threads. And let's say this method changed the variable message. You don't want to be in message was static, and you don't want to change it at the same time, or else, different things could get different results, and things will not turn out how you pictured it. So if you're doing that, you might want to use synchronized, just in case. So, yeah, starvation is when one thread can't do anything because, it's waiting a very long time for another thread to be done with it. And sometimes that can take, potentially forever, depending on what you're doing with it. So starvation is also bad. Now the next is live lock, which is like deadlock, since, they're similarly named, but instead of being stuck because they can't do anything with each other, they're stuck because the only thing they're doing is with each other. So let's say public, I don't think I can, maybe I can. Public void move. Cool, I can do that. What is... yeah, I can understand that. Oh yeah, I can't call it directly. No problem. Sort of. Oh yeah, I'll just make a new class. No big deal at all. Let's just say public static class custom thread extends thread. And this is going to be, very similar to, what we have here. Except just some extra work, so private custom thread. Then move ct.move. So if we actually did this, redundant process, and then so this is just really redundant. Obviously, I'm setting up the ideal conditions to have these, misfortunate things occur, mainly for the sake of explaining it to you. So if we start this, what we should just add real quick is system.out.println moving. So we started this right now. Look at the console, that's a lot of moving. Eventually, there's this extremely long error. This is a stack overflow error. Exception, I mean to say, stack overflow exception, which if we can scroll to the top, we can actually see. Yeah, stack overflow error, actually, not an exception. Which is, errors are worse than exceptions. Because the main thing, if we looked ahead of all this, which actually it's too long to look ahead of, but what was happening is that it was saying moving a hell of a lot. So each of these threads were just responding to each other in kind by responding to each other, etc., etc. So the thing is, these things were doing so much stuff with each other that they were too busy to do anything else at all. So they were stuck in an infinite loop of doing stuff with each other, which is live lock, which is the opposite of deadlock, but just as bad. So that's the main thing about advanced threading. Now, there are a lot more about threading, which I might do an episode in the future. I mean, obviously this This is a while before, but you know, threading definitely has a lot of higher higher tiered topics and things to learn about threading, which you know I may very well do a future episode on or two. But until then, this has been episode 11 on advanced threading, and I hope to see you next time.